Hey there, Seahawks. It's Miss Adams, and in this video, we're going to go over how to estimate a population mean. All right, so the formulas for working with means for a confidence interval, we have x bar plus or minus z star times sigma over the square root of n. This is not often used. We only use this when the population standard deviation is known. If we know the standard deviation for the entire population, which is very rare, then we can use this formula. Otherwise, we're going to use a different distribution called a t-distribution. This is when the population standard deviation is unknown. So for the confidence interval, it's x bar, which is the sample mean, plus or minus t star, our critical value, times s, the sample standard deviation, over the square root of n. All right, so critical t values. You are interested in calculating a 90% confidence interval for the population mean with a sample size of 31. What is the critical value you should use? So the sample size is 31, and when I'm working with t-distributions, we have to find something called degrees of freedom, which we abbreviate as df. So we have a 90% confidence interval. That leaves us with 5% on either side. And our degrees of freedom is always n minus 1. So our degrees of freedom would be 30. And so the area to the left of our cutoff point would be the 90 in the middle plus the 5 on the tail. So 95. So we would go to our distribution menu, second vars, and then inverse t. And area would be 0.95. Degrees of freedom would be 30. And when we put that in, we get 1.697. So that would be our t star. So there's not really some t star values to memorize because they're always dependent on the degrees of freedom. So there's too many of them at 90, 95, and 99% to really memorize. But you want to know how to calculate these using your calculator. All right. The conditions are pretty much the same. The random, the independence or 10% condition, and then the normal condition. The only one that's a little different is checking the normal condition. Requires some stuff different. Random is usually stated. The 10% condition is where our population has to be greater than 10 times the sample size. And the normal condition, it's either going to be stated that it's from a normal distribution, or you're going to use the central limit theorem. And we can use the central limit theorem if n is greater than or equal to 30. All right, so the interpretation, when we found our confidence interval, how we interpret it, we would say we are whatever percent confident the true mean in context of the problem, so the true mean, blah, 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 is between blank and blank. You want to make sure that you use the units and that you use context of the problem. All right, so estimating a population mean. Researchers took a random sample of 20 adults and found the mean pulse rate to be 72.69 beats per minute, with a sample standard deviation of 3.86 beats per minute. Construct a 95% confidence interval. All right, so we're going to follow this 4-step process: state, plan, do, conclude. So state, I'm going to kind of put everything that I know. Mu is the true mean, the population mean, pulse rate of adults. X bar, which is my sample mean, was 72.69. S, which is my sample standard deviation, is 3.86. And my sample size is 20. That means degrees of freedom is n minus 1, so 19. And they want me to do a 95% confidence interval. So C is 95%. Plan, I'm going to check my conditions. So random was stated. Independence, there are more than 200 adults because my sample size was 20. All right, there are more than 200 adults because my sample size was 20. And then pulse rates follow a normal model. So they didn't quite say it was normal, but we know that pulse rates tend to follow a normal model. All right, do, we would go into our calculator, stat, go over to tests, and then look for t interval. And then we're going to put in the data as stats. We'll put in x bar, s, n, and get our interval, which is 70.883 to 74.497. And then we can interpret it. So we would say we are 95% confident that the true mean pulse rate of adults is between 70.883 beats per minute and 74.497 beats per minute. All right, so to show you these steps here in your calculator, so we are going to go to Stat, and we're going to go over to Tests, and we are doing a 1 sample t interval, so it's just going to say t interval, which is down there, option 8. All right, typically we use Z for proportions and T for means. We have the option between data and stats, so we're going to use stats. X bar, we're going to enter in as 72.69. SX, the sample standard deviation, we're going to enter in as 3.86. N, we're going to enter in as a sample size of 20. And then our confidence level is 0.95. So I hit calculate. And we get 70.883 to 74.497. So that's how you do that in your calculator. All right, go Seahawks.